Hi, folks. Welcome again. Thank you so much for coming, by the way. And in this video, we are going to have another case of reservoir simulation using tNavigator software. And today's topic is particularly interesting. It's about modeling or simulating hydraulic fractures within our model. All right. So again, we will use sample case from tNavigator. It's very good of them, providing the users with very, useful examples. And yeah, we are going to discuss about that in this particular video. All right, so we are looking at our model, two-dimensional map, pressure and saturation of oil, and then gas and others. Actually, there is no special thing about the grid itself. Okay, but maybe we can check the permeability. We are currently looking at the roof view, and let's change it to average. Okay, even in average value, the permeability is not that low. So yeah, but still you can conduct hydraulic fracturing. Okay, so we can change it to 3D view like this. And maybe if we are talking about drilling or if we are talking about production performance, we can show either saturation of oil maybe and pressure, of course, but the pressure is uniform across the reservoir. But we can also check the fluid in place, mobile in place, for example. But by the way, that's not the main thing. The main thing that we are going to discuss or we are going to learn is, of course, about the fracture. And currently, if you look at the compass here pointing towards us, and the point is directed to the north, but I think I prefer click on this one, flip vertically. So that side, that direction will be our north. Okay, and then that's for the review. And let's check the files. Click on this one. And then you see here, currently we have no user file, right? But later on, we will produce user file because we will create our fracture. And if you look at this master data, run spec, nothing special, title, metric unit, unif out, oil, water, this gas. Okay, nothing about fracture here. Okay, maybe in future video, I also will show you about generating fractures using keyword. Okay, in this one, we will generate the fractures using the user interface. Okay, here there is no keyword that tells us about the fracture. And grid, we have grid ink, perm X, perm Y, perm Z, and then props. This is important, the relative permeability. Okay, this is the relative permeability table. This one, these are important. Flow function, propans, but we will talk about this later. Okay, so that's it. And before placing our fractures, we first will run the model. Okay, I want to show you the comparison of the production profile before and after the fracturing. Okay, currently we are calculating. Hopefully it's not slow. All right. Okay. So yeah, we are currently looking at the 3D view of mobile in place distribution. And now let's discuss a little bit more while the model is running. So we can go to fluid properties here. And as usual, we have relative permeability table, PVT, water, oil, and gas, rock compressibility, density information. Okay, again, this is the relative permeability. All right. And here, or maybe this one first, propan. Okay, the propan, the information of propan is located within the fluid properties. Okay, and this is about the permeability of the propane pack. Okay, so before, yeah, if you really want to understand about hydraulic fracturing simulation, you need to first understand the hydraulic fracturing itself. And in hydraulic fracturing, we use propane, okay, to withhold the fracture, the open fracture, and to prevent the fracture from being closed again. Okay, and we know the propane, we know that the propane pack will have permeability. All right, and in this case, we have two propanes, propane 0 and propane 1. Propane 0 green color, propane 1 purple color. And this is the table showing us the permeability as a function of pressure. Okay, so in higher pressure, we are talking about hundreds bar here. The permeability becomes lower and lower, smaller and smaller for both propane. Okay, so this is the user interface, but if you want to create this kind of information within the keyword, you put that under the, props. And in this case, we have the information for propane in the relative permeability keyword on in relative permeability file. Okay, so after we have relative permeability, we can put the keyword, this one, n propans, okay, to tell tNavigator that we will have two package of propans. Okay, and the keyword propan names to tell tNavigator I have two propans and the names are propan 0 and propan 1. Okay, you mentioned the first propan first, propan 0, and the second propan, so that later when we create the propan table using this keyword propan table, the the first column will be the pressure, and the pressure is presented in metric unit, bars, right? And the second column will be for the first propan, and the last column here, the third column will be for the second propan. Okay, and of course you put slash to close each of this keyword. So also slash there and slash for propan names, slash for n propans. Okay, so that's easy. Okay, if you want to use hydraulic fracturing, you put propans and give information about the propan on the keyword. All right. And then we also have another thing. I'm going to close it a little bit. Flow functions. So we also have flow function, two flow functions, each for each of the propan pack. Flow function 0, flow function 1. So what is flow function? So flow function tells the simulation that the propan or the fracture will not last forever. Okay, later on, the fracture will close again. Okay, and of course the productivity will be reduced again. Okay, so the performance will decline, not because of the pressure, but this is the inherent limitation that the fracture has. Okay, there is no permanent fracture actually in the world, so we want to represent that decline of the fracture performance by using flow function. And we have two types of flow function here. The first one is linear, okay, from the flow function 0, the first one, and exponential decay. This is the table, but it's actually generated from the correlation or the equation. So we are the one who put or who provide the correlation to tNavigator, and we give that in terms of, keyword. Again, we can put that under the props. Here in this case, they put under or in the same file as the relative permeability. So we have that flow func, the keyword flow func, each keyword flow func, each for the propan. Okay, so the first one, you give the information regarding the name, flow func 0, that's the name. And then the second information is about whether it is linear or exponential. Okay, so flow func 0 will be linear. And regarding these two numbers, 0.99 and 1, I think you're going to need to read the manual. I'm not going to explain about that, but actually to express the either the line or the curve, you need two values. You need two numbers, the first number and the second number. Okay, and yeah, so to create this kind of line, you give two values, and the value is 0.997 and 1. And to create this exponentially decaying line, you use this one. Okay, I'm not going to explain about that. Yeah, it's a little bit mathematics there. So yeah, you can just go open the manual and read it for yourself. Okay, but actually we put this correlation, we put this equation on the file, and we put the keyword. Don't forget to close the flow func with slash and close this line with slash. Okay, and yeah, later the tNavigator will use this equation to generate this table. All right, so far so good. By the way, we have completed the equation or the running, so we can check the production. So the production is like this. Later, we are going to the previous time steps and perform hydraulic fracturing. And of course, the production profile will be different. So remember this shape. Okay, in particular, we can check the production from producer 5 like this. We will we will fracture this producer 5 and production or producer 6. Okay, and maybe this well, this is horizontal well. Later they will be changed because we want to frac them. Okay, so far so good. And then after the flow func, okay, so let's go to frac the well. First, after completing this one, so you know already the production performance of the field and from each well. So let's go back to certain time step, for example, here in this case, to time step 1. And on this time step 1, I want to frac producer 5. So let's find it in using this one, prod 5D. Okay, so there you go. This is the production or producer 5. Just remember the profile here. Okay, so it's like this. So at time step 1, the flow rate is 162 standard meter cube per day. This will be changed. So let's just go back to grid properties and then right click on this grid and then edit well producer 05. Okay, so this is the original view. And then let's frac all the layers. Touch this one, hold shift button and touch the 10th layer and everything will be blocked. Okay, everything will be highlighted. And then you see here, previously it is inactive, but now shift it it's activated. Click on that one. Okay, here the frac options. We want to create the fracture manually, so click on that one, select manual, and yeah, the first one is azimuth. I'm going to make it 90 degrees, and then zenith angle 0, and then height 1 and 2 0, and then length 110 meters, and then 140 meters for the length 2. So it's not symmetrical. All right. Length 2, I make it, longer than the length 1. and the width of the fracture 0.02, and then bounding box, click on that. So what is bounding box? So the first and last layer numbers in X, Y, and Z directions. So basically that you define the first and the last layer numbers from X, Y, and Z direction. And the fracture should not be outside this box. So by saying this X11, X22, I'm telling tNavigator that, that my fracture should not be outside this box. Okay? And the same thing with Y, Y1, Y2, and Z1 and Z2. Okay? By the way, let's go back to definition, or maybe later. Okay? And yeah, tick on permeability, and then we select the propane pack that we will use in this particular fracture. So we are going to use propane 0 with the associated flow function 0, multiplier 1, and the phase, either liquid, water, oil, or gas, depending on your model, depending on your reservoir. In this case, we are going to select liquid. Okay, so multiplier is fracture productivity multiplier. Again, propane and flow function you choose from the drop-down list. Okay, and then azimuth can be 0 up to 360, zenith from 0 to 90. All right, and then again, this bounding box means that your fracture will be contained here in this bone. And again, azimuth in tNavigator is the angle between the positive direction of x-axis and fracture right half length. Okay, so that's why I use the north there. Okay, this is the way it should be, so that I know that the positive x direction will be to my east. Okay, this is x direction from west to east, so the positive x direction will be directed to the eastern part. And again, azimuth angle is the angle between positive x direction and the fracture right half length. So I have left and right, left and right half length of the fracture. So the azimuth will be the angle between the positive x direction and the right section of my half length. Okay, sorry for if it is a little bit, complicated, or it makes you confused, because yeah, I think because it's a little bit, it is, it takes time to understand, and better you read it yourself. And then I think, yeah, there, I will show you the generated fracture. Maybe we can understand better. And then, okay, click on OK and save. Okay. All right. So if we untick the show grid, nothing happened, but the fracture will be generated at the next time step. So click on this one, move to the time step 2, and then select fractures D. All right. If I back to the first time step, there will be no fracture. Fracture will be created on the next time step. So click on this one, you see my fracture. Okay, so previously I tell tNavigator that the azimuth angle will be, will be 90 degrees. So it is. Positive x direction, D, to my eastern side, and the azimuth 90 degrees. So that's why my right here, my right half length D. So the angle between my right half length and positive x direction is 90 degrees. Okay, and show tick again, show grid again. So that's it. And what else? It's so far so good. And then let's go to frac the second well. Show grid again. And now I want to frac my producer 6. Right click. And I, by the way, want to frac it at 4 time step or maybe 5th time step. Let's check the profile first. Producer 6, so it's like this. So I want to frac at 5th time step, so something will change around this time step, or actually after this time step. Back to grid properties. Here our producer 6, right click, edit well. Again, I want to frac all the layers, press hold, generate fracture, manual, and then now the azimuth 110, and then the rest will be the same, bounding box. Okay, so this will be the boundary of, or the limit for my fractures in X, Y, and Z directions. Permeability, now I want to use the first or Propane 1 and flow function 1, and multiplier, for example, 3. So the productivity will be boosted by the fracture. And in this example, in this particular well, we can check, or we can try using the phase time. Okay, so the performance will change as a function of time. Later we will see that. And okay, all right, what else? Click on OK, and then again save. All right, and then untick show grid, move to the next time step so that you see your fracture and the angle, the azimuth is 110. So a little bit deviation from 90 degrees azimuth. Okay, you see that? Okay, so all right, and we can go back to the original, the 0th time, and just remember the production profile, and then we can run again. After you run, you see we have created this user file. Later we will check that. Okay, so let's go to the producer 5. You see at the second time step, the flow rate is 160, and then after that 184. Of course, there will be change because we frac. Now the flow rate is 250. The productivity is improved. And on the same way, there is change at the producer 6. Okay, now we reach 5th time step. The next date, boom, now the productivity increases. You know, we reach 400 oil rate. Okay, all right, but you see during the phase we select time, so clearly, you know, the productivity declines is a function of time. So after the spike of the production, the productivity declines, the production declines following our flow function. Okay, so that's very good. Okay, and yeah, the production will be back right after 1 year, because that's what we say, you know, in the flow function. The production will be back around 1 year. Okay, Fracture effect decreases soon according to exponential flow function that we provide. Okay, so this is for production or producer 6. Producer 5, the productivity also declined, but following the linear trend that we provide in the equation, in the flow function. Okay, the decline is not as dramatic as producer 6. You see, dramatic productivity decline. All right, and then what else? By the way, we can also open the well and we compare it with wells with no fracture. If you open them, it's like this. It's the connection between the well and the grid. But if you frac your well, you will have two types of connection. The first one is the original connection, and each connection has their contribution on the production. So the production profile from each connection will be different. And if you open the virtual connections, we will have more layers. So you see we have star symbol here. This is for virtual connection. Virtual connection generated because we frac the grid. Okay. So in fracturing the grid, we have virtual connection and they also have their own, contribution of the production. Okay. So you have connection and virtual connection there. Okay, the real connection is this connection and the virtual will be shown with stars here. Okay, now we complete the time step again. Let's see the field production. So a little bit changed there, okay, because of the fracture that we provide. And then let's say we go back to the previous time step 13. Okay, now we are going to frac another well. Oh yeah, by the way, let's check this one user file that we generate. Okay, because we frac the well, we will have some other keywords. Well track. Okay, well track for producer 5 and producer 6. Previously, we don't have this user file. This user file is generated by tNavigator after we put the fracture and run the model. And then this is the date. And this is the date where we put the frac on producer 5. Okay. All right. And then this is the length, the first half length, the second half length. This is the degree, the azimuth. And then this is the fracture width. This is the propane that we use, flow function that we use. This is the phase liquid and the productivity multiplier 1. And then this is, this is the bounding box. All right. It actually, resemble the table that we have or the window that we have when we generate the fracture using user interface. Okay, and then this is the location for I39 to I39, J14 to J14, and K2 to K11. And then this is the second time step, next time step, and then we again have another frac. Now it's for producer 6 with the same configuration of information. Now we use propane 1 and flow function 1 and the phase time, but you can also use liquid. All right. Yeah, you can exercise it by yourself. And this is next time step. Okay. And again, yeah, after this one, tNavigator will follow the schedule, the rest of the schedule, which is this one. In the schedule, there is nothing special. Okay. Of course, we have well spec, com.md, and so on and so forth. So let's close this one, and then let's add another frac. And in this, now I want to frac this one horizontal well, WU. Yeah, so there you go. And if we untick the show grid, this is actually a fracture, or this is actually a horizontal well. Okay, so I'm going to tick again, and let's put our block here, right click, edit this well, and I can frac only a certain layer. Let's say I just want to frac this third layer, and then generate fracture. Okay, and again manual, and now 90. The same bounding box. Oh, by the way, let me close it a little bit. Definition. So here, NX we have 72, NY we have 70, NZ we have 11. So we put or we use this NX, NY, NZ as our bounding box. You can use even smaller, you know, numbers of grid for your bounding box. That's also okay. That makes sense. But in general, we can use this maximum NX, maximum NY, and maximum NZ. Okay, let's go back to grid properties, right click, edit this one, generate fractures, manual, bounding box. So 1 to 72, 1 to 70, Z 1 to 11. Okay, from 1 to maximum number. All right, and then azimuth 90, and then the same. Permeability, let's use permeability 0, flow function 0, multiplier, for example, 2, and then phase, for example, liquid again, and then click on OK and save. All right, and then move to the next time step, untick show grid. You will see our frac there. Okay, and yeah, by the way, it has been relatively easy so far, right? Yeah, hopefully we can we can learn also again about making the fracture using keyword without relying on the user interface. It's possible, by the way. All right, and then I think it's okay. So let's untick, or let's tick again the show grid, and then we go back to the previous time step, maybe time step 10, and then recalculate. Go to graph. Let's check the production from horizontal well. This is the original, and let's click on this one. Something will happen around time step 13 because we frac the horizontal well. Boom, right? So production increases, productivity increases. And don't forget, we will have decline, okay? We put on the flow function a linear decline, okay? And basically, if we go back to fluid properties, yeah, it's flow function, so it's dimensionless, becomes smaller in volume, smaller in value. And again, if we go back to files, now we have another, user file, because we create the fracture in the next well. So we put that on 1st November 2008. We will have well track again, and this is the December, and then this one January 2010. Okay, yeah, we put the well track. tNavigator puts the well track on this date, and then the frac we put on actually January 1st. Okay, that's the 13th time step. So the keyword, by the way, is W frac P. Okay, W. So what W stands for? I think it's for well, maybe. And then frac is of course for fracture. And P, I'm not so sure, but maybe it's for producer. Okay, and again, this is the name of the well. This is the I location, 28, J or Y direction, Y location, J location, 63, and then Z or K location, 3. Azimuth 90, and then this one, the first length, half length, 110 meters, the second half length, 140 meters. This is the propane that we use, width of the fracture, flow function that we apply. This is the phase, productivity multiplier 2, and then this is the bounding box. And after that, the next time step. Okay, so again, if you don't want to use the user interface, you can actually use this configuration. Don't forget to use the keyword and put slash to close the keyword. Okay, so you can just you know directly put these keywords and informations on your schedule file, include file. Okay, and maybe one last thing, or maybe the last two things I'm going to show you. Okay, I'm going to close this one first. Let's see the streamline. So go to grid properties and then tick the streamlines here and then untick the show grid. You will see all the streamlines. And if we go to two-dimensional view, tick streamline there, you can see. Okay, but we can go back to 3D view and let's focus on the fracture there. If we untick the well, click this one, user well filter, deselect all, just show the producer 5 and 6, and this one, click on OK. Oh, you cannot see the streamline. Yeah, maybe the streamline needs all wells to be shown. So let's go back to select all. Okay, because yeah, streamline is the connection between producer and injector. Or maybe let's maintain the injector, deselect all, producer 5, 6, and horizontal well, and the injector. Okay, so I think it's a little bit better. Okay, so clearly we can see that the fracture, all the section of the fracture contributes to the flow. Okay, we see that all fracture is working on or working with formation. All right, and we can also lastly use user cut. Okay, let's go to user cut here, or maybe untick the streamline, tick the show grid. Okay, this is for cut. And in arithmetic command line, let's say we type in WMC, okay, and then open parenthesis, type in this one, and then star, this one, and then comma 1. Okay, and let's apply. What happened? Use cut. Okay, so wow. Yeah, You can open the previous video, by the way. I also show you about this one. So WMC, W for well, M for mask, if I'm not mistaken, and C for connection. So we want to find the connection between well and the grid, between well and the model. So yeah, we see all the connections. This this star is for mask, and comma one means I want to show all my producers or all my wells. Okay, that's why you see all wells here with the connection. You cannot see some producers because I deselect all. So I can also select all, and you see all wells with their connections. So that's the meaning of WMC. And now I want to put second row plus. So the cell or the grid must follow or must comply with the both rules. And the second rule is 2 star WMVC open parenthesis, this one star close comma 1, this one. Okay, this is to select the blocks with open virtual connections and with standard connection with different color. So click on apply. Okay, so we will have different color. So WMVC is actually W for well, M for mask, V for virtual connection. Okay, and because I have them in separate rules, the color will be changed, or the color will be different. And then both use comma one means it's for all producers. I want to find all, sorry, I want to find all wells. That's the meaning of comma one. Okay. And this one, parenthesis, this one, and then star, and then comma one can be replaced by well mask and parametric expressions for wells. For example, yeah, we can change it to, yeah, by the way, star is for mask. We can show you, for example, quote prot star unquote comma or at greater than 20, for example. Okay, let's delete it first. Okay, so this is to select connections for wells which name starts from prot and oil rate is greater than 20. Okay, so you can see that, right? So this quote prot and then star unquote it for the name. Okay, so I have prot, prot there, prot there, prot there. You can see the connection. Injector, you cannot see the connection because it doesn't meet or they don't meet the name prot. And then ORAT greater than 20, only several wells survive. Disconnection, disconnection, disconnection. All the connections shown are for wells with oil rate greater than 20. Okay, I think that's pretty much all. So we have covered many things about simulating hydraulic fracture in tNavigator. So hopefully our learning today is beneficial for all of us. And see you on the next tNavigator videos. Thank you.